Hi, my name is Doug Schnoebelen. I'm happy to be here with you today, even though this is a little different event than we had originally planned several months ago. And today I want to talk to you a little bit about some of the new tools and technology for our next generation water data. And for us, USGS and water, as you know, it's all about the data. The USGS has nearly a 140-year history of providing science data, and we maintain many gauges across the network across the nation there, 2,100 water quality stations, 8,200 stream flow gauging stations, 1,700 groundwater monitoring wells, and 1,000 precipitation stations. We make thousands and thousands of discrete measurements every year. But if you look at our stream gauging network, which is very extensive when you look at this map, yet that's less than 1% of all the streams across the United States. There's a lot of areas that we can't cover. There's a need for new and emerging technologies, certainly new infrastructure and technologies. First steps there are some of the flood-hardened gauges we've already put in with the Texas Water Development Board and the governor's mandate. The new radar and video imagery that we're doing, and new sensors for water quality and suspended sediment. Lastly, we want to be able to predict using our models and new tools. So this next generation water observing systems that I'm talking about there, if you want to take a look at the slide there, is really to identify the gaps in the monitoring areas, these new fixed and mobile monitoring assets that we have. I'm going to talk about a few of those today. And then the integrated delivery of those water quality and quantity and how we use them. And then working with the partners and stakeholders. And that's really where everybody here at the conference comes in. We're here for a science to serve others, other state agencies, local agencies, and we hope that some of this new technology, some of this will be of benefit. Okay, so the next generation water observing systems, approaches and advantages. If you take a look at the slide there, you can see that. I won't necessarily read through all those, but I think you get the idea that the increased spatial and temporal coverage, the high resolution, we can get into areas that we couldn't get into before. And we're hoping with a lot of this new technology that eventually we're going to be able to get better data with lower costs. Okay, so what do I mean by next generation? That's really a lot of the new technology and tools. Some of this we've already employed, some of it's cutting edge. That has to do with the drones. Cameras and thermal images, and we can do geophysics with those. There's a picture there of a drone with a ground penetrating radar unit on it to look below the water surface. We do things with remote sensing, again, video cameras, radar units, hydroacoustics. And then water quality, many of those new parameters in water quality now with sensors and things are really coming into their own. Okay, just a few of these with some of the water quality monitors that we have in place. There, if you take a look, we've got nitrate, as we've been doing for a number of years, pH, specific inductance, dissolved oxygen, temperature, chlorophyll. These are important for ecology and trends, the health of the water. We can look at harmful algal blooms. And then turbidity also for sediment loads. We're doing a lot of that as well. Okay, if you look at the screen there and you take a look at this is just showing some sensor data. This is some data I collected back in the past quite a while ago. But if you look at the monthly samples there in yellow, this is for some streams up in the Midwest. That's the discrete samples, but look at the real-time samples for a nitrate there. Much higher resolution, much better resolved system that we can now stream directly to the internet. We're using this in San Antonio for the city of San Antonio right now, and San Antonio water system. This is the nitrate level. Again, if you take a look here with the rainfall on top, nitrate there in black, the water level, you can see in the aquifer, when that water level comes up, that nitrate level goes down. And that's as that gets diluted. And that happens in a matter of really a few hours. So we would not be able to pick that up with traditional measurements. One of the examples I'm going to go through today for you is in Bandera County, and that's some early flood warning work that we developed using a number of these tools, and we're starting to put some other things out there as well. So, as in most places in the hill country, we need early flood warning. We know that the rain comes through very quickly. Often our existing gauge data is not dense enough, and sometimes we can't put stream flow gauges in every place that we want to. Okay, so if we take a look at the map across the area, all the black triangles are existing gauging stations, and those are some of the new ones that we put in red there across the area. And you can see there's other places we'd like to have gauges too, and we hope to be able to expand this out in the future. Okay. This is the basin right around Bandera that we're concerned about, and then the Sabinal Basin as well that we have studies in. So the approach here, if you take a look at the slide, is really, and this is the way we do a lot of things, is we look at the infrastructure. In this case, we're looking at flood inundation maps, analysis, and then getting the word out. So those three things are key. Okay, so this is the building it part. As I said, we put in some new gauges there up on the north prong and west prong of the river system. There's a Bandera there. And that's what some of those sites look like. Same thing on the Sabinal. We had a number of sites there that we had to revamp and add in. And then the other part of that, and this is the part of some of the new technologies, some of these temporary stage sensors. So in areas where we cannot put our traditional gauges, and this is one way we can save some money as well, is we have 5 here independent. These are these little pressure transducers. You can see them. We've mounted them to the bank and the trees here. And we collect some of the data from those from high water levels. And then we also do a continuous slope discharge area across that. And here's some of the temporary stage sensor sites near Utopia that we've been able to put in. And with this continuous slope area, the stream flow is calculated by using measured cross sections, channel roughness, and continuous water slope elevations using these sensors. And if you take a look at the graph there on the bottom in green, you can see that usually we need at least 3 or more pressure transducers to record the event, but we can start to develop this stage discharge curve. And this is a really powerful tool in helping us aid our stream gauging network and being able to understand flow much better than we would normally. The other part of this with our flood inundation mapping is once we collect all this data, we need to feed that into some sort of model. That's our goal, because we want to get to predictive ability. And the flood inundation mapping, I mean, this is a whole nother talk in itself. But basically, you're looking at the geometry data. We're using a HEC-RAS model. There's other models we use. There's roughness data goes into that, the stream gauging data. We go through several iterations of model calibration. And then finally, the flood inundation map is the part that we want to get to. And here's an example of flood inundation map, Medina River near Bandera. And the 100-year or the 1% exceedance flood level there, stage level, is shown in the blue, and you can see how that flood wave spreads out across there. We're very happy to note too that our model matched historical data. You've got a picture there, courtesy of the Judge Evans. This was in 2002, the tremendous flooding there, and our model predicted exactly where the flood was going to be. Or was. Okay, then the last part of this is, I think, really the communication part, and that's getting the word out. It's not enough to have the new technology. It's not enough to be able to create the fancy models and stuff. If it doesn't get out to the public, If it doesn't touch people, it's really not much use. So there's a number of stakeholder meetings we've had, also with emergency managers. All this is on our web-based tools and support. And I just alert you to a few web sites out there that we have this on. The Flood-Inundation mapping program shown here is where we put all the flood inundation maps that we created. Also, we have the Texas Water dashboard. This is all our gauging networks, and you can click on those gauges and pull up that information. I'm proud to say that the Texas Water dashboard, this model of displaying data, is now went nationwide for the U.S., and that was developed here in Texas by many of our team in the center. The other part of this is Water Alert, USGS Water Alert. You can get this on your phone. Real-time stream flow information. You can just subscribe to that, and you can pull up the graphs on your mobile device. The same thing, another app there is the USGS Water on the Go app, and that will, when that's turned on, it will automatically locate the USGS gauges nearest to your location and show you the graphs there displayed for the output. Okay, so lastly, I just wanted to list the, I know I threw a lot of information at you there. I wanted to just list some of the websites there for you. You can click on those and find a lot more information. But very happy to answer any questions and anything else I can provide for you. Thank you.